Okay, so we are online. So how do you guys want to do this? Because I know we kind of have to decide starting now how we want to do it each week. You guys want to work through all of them? Do you want to just like assign some each week that we work on together? Because I was kind of reading on iLearn and kind of said we can do it however we want it and like teach each other, or we can just go over it and help each other when we get on. What do you guys think is better?
I kind of like the idea of assigning problems to each person, and then when we got on kind of teaching each other, because I read over that too and I thought that was a great idea. So then we could just focus on one or two.
Yeah, it's probably a lot easier that way.
Yeah, because I don't know about you guys, but this took me like 2.5 hours.
Oh my gosh.
It takes so much
There's
time.
still a couple problems that I don't understand.
Yeah. So it'd be nice if we could divvy up the work and then teach each other. I like that idea.
The problem that I had too is it was like some stuff I knew how to do right away, and others I just had to look in the book. And like vectors, I just really didn't get vectors. I don't know. Maybe I just didn't read the book enough, but I didn't find the video to be extensive enough for what we needed to know.
Yeah, the book didn't really help with question 3 at all.
Yeah.
Yeah, that was something I don't want to do.
Yeah. So maybe we can like assign the questions that we're going to work on, but then we could also, if we have a problem with that question that we're assigned to, like get on the discussion board and talk about it before the meeting and just say like, hey, could somebody else take this if they understand it? Or like, can somebody look at it and help me out with it? Something like that.
Yeah,
that works.
Does that work? Okay. And then as far as posting the work, I don't know if somebody wants to like be in charge of creating a document, because I know he said something like using Google Docs to make a document, or I just assumed we could like scan in one piece of work. I don't know.
Well, so yeah, I was wondering that too, because it's like if we need to scan in or like take a picture of the work we do on paper, and if we're all doing different problems, should we just have everybody take a picture of all your work of your 2 questions and then send it to somebody each week?
Yeah, well, and that's what I thought. Or when we talk about it in here, we just kind of walk through the steps and have somebody write it, as you know. But then that's kind of hard too, because then we have to talk through every single part of every single problem.
Yeah.
And that's probably not very effective either. So, I mean,
I like that idea of that you mentioned that when we're working on our individual problems that we've been assigned, obviously this week is different, but then just take a picture of that work, send it in as a PDF, and then we could all just, have it combined later. So do that beforehand as well.
Because he said something about putting it on a Google Doc, but I don't know how we would put work and stuff on a Google Doc. I feel like that's a lot of work. To try to do everything.
I can put it on a Google Doc if you guys want me to.
Could you do that if we?
Yeah,
how would it work?
I'll put next week's onto a Google Doc.
And then you can share it with us.
Yeah,
and
so
everybody
everyone can work on it at the same time.
That works. So everybody kind of does their problem, and then they can put their work on the Google Doc, is what you're saying?
Yeah.
Before the meeting?
Before the meeting. So the document should be filled out completely before we start the meeting.
Yeah, I like that.
That is a good idea.
Awesome. And then, Mason, would you be able to submit that, and I'll submit this, or do they have to go in together in the same post?
I don't think they do. I'm not sure. Let me look it up.
If not, if it's a Google Doc, then I can always just connect it with the video.
Yeah, I don't. He didn't say what file it had to be, so it could be a Google Doc, I guess, or PDF. I don't know.
Yeah. Okay. Then let's plan to do that. As far as this week goes, maybe I don't know. Does somebody have all the work done? Like, I have a couple questions unanswered. Does anybody have?
I finished mine.
I have 3 questions.
So, could you take a picture of yours when we're done and send it? We can just send that one for this week.
Yeah, I can do that.
Okay. Cool. All right. Anything else that we need to talk about before we get started on the questions?
So does this time work for everybody for the rest of the semester?
Works for me.
Yeah.
Yeah, this works.
Okay. Awesome.
Cool. Okay. All right. How did you guys do with number 1?
Number 1 wasn't too bad.
I didn't think so.
I agree.
Yeah.
Does anybody want to share what they got? Or what they said for that? You can pull it up.
I put that 2 doesn't work, but you can have 3 or more, and that would work.
I put the same thing.
Yep. Because it says that they have to be of different sizes, so it doesn't work if they're different sizes. Yep, that's exactly what I said too. That one was really straightforward. All right, number 2. Let me see if I can screen share the problems. All right. Whoa. Weird. I don't know how to do that and pull up my screen.
I think you just click that and then click onto your tab or whatever that has.
Yeah, if I can get to it. Let's see.
Nice. There it is.
Can you guys see it now?
Yeah.
Yep.
All right, then I'm just going to leave that. Let's hide that. Okay, so number 2. How did you guys work for this one?
What I did is, I don't know if this is right, but I just used the Pythagorean theorem to find R. And then after that, I took the tangent of sides A and B to get that angle.
What are the answers that you got?
So the answers, so I got for R, I got 30.8 meters approximately. And then for that angle, I got 54.25 degrees.
Okay, that's what I got too.
Yep.
Yep.
Same here.
Whew.
Awesome. Any questions with that, or we can move on to number 3 if not.
Think I'm good?
I'm good.
Okay.
Okay.
All right. Number 3 was challenging for me. So
I didn't figure-
I don't know if anybody knows what they're doing with that one.
I have mine. I can show you mine if you want.
Yeah, if you want to do that.
Let's
I'm gonna
pull
have
this up
to.
quick.
Whoa. All right. I'm gonna stop sharing my screen.
Okay, so this is what I got. So I was using the law of cosine to find the missing sides. So basically the same thing, just use a little more trigonometry. So for VA, I took the cosine of the angle, and then basically just solved it with cosine 26 with the opposite side, which is a 6.72, and found x. So for VA, I got 6.01, and then for VB, the same thing, got 3.
That's what I got.
Okay. I was looking in the book, and I was looking at that problem, and I had the same exact problem in the questions, and it says view solution, and it said the x component. Maybe this is the wrong one. Let me see. Oh, never mind. I don't know what I'm looking at because it says that the numbers were different. It said x component is 4.41 and y component is 5.07. But I guess that's the length of x and the height of y. So maybe they were solving for something different, but that's where I got confused because I looked at this in the book.
So I got a different answer. I'm trying to figure out why. Then again, I was all over the place on this question. So here, could you share your screen again, Mason? I just want to see exactly what you did. Because I did the same thing. So I found what do you call it? The x total on the bottom. And then the total over on the x-axis it goes, and the total height it goes. And then I plug that in. Let me see here. Okay, so. Yeah, I don't know what I did wrong, but yours looks more correct than mine does.
Yeah, so I just did cosine of 26.5 equals x over the 6.72. And so you move the 6.72 over, and then you find the cosine of 26.5, times it by the 6.72, and that gives you your x. At least that's what I thought you're supposed to do. It's been a while since I've taken trigonometry or calculus, so.
The only thing that I looked at mine and figured out what I did wrong. The only thing I did wrong was with VB, I used cosine instead of sine. So that was where my mistake was. But other than that, I got some answer now that I've reworked it. So.
I could see what the book was getting at, though, because I did it as well the other way that got me the answers that the book got. And you just have those two bottom angles, that 26.5 and the 22.5 right below the VA. So that gives you a total angle of 49 degrees. And so with that angle, you can find, and assuming that VB then straightens out, I don't know how they got it. Anyways, but you take like 6.72 times the sine of 49 and then the cosine of 49, and that's how you get those answers. So it's like straight up and down. Like if you were to use the triangle and find just the x and y of that total, whatever it is. So yeah. So that's how the book did it.
Yeah, because in the book at the bottom it says find the components of V total along the x and y axis. So that's why, because that must be what they did to find that. So they were solving for a different question than what we were solving for. But it's part of the same problem. But yeah, that makes sense why I would do that way. Okay. That sounds good. Okay, number 4. What do you guys think?
So I had a question on this, because I mean, technically, what relative direction between them produces the resultant with the greatest magnitude? Technically, wouldn't it just be 0 degrees? So it's like vector A goes, and then vector B continues going the exact same way, or does that just make it one big vector? Would you need to offset it by at least 1 degree?
No, I said that it was fine as long, like at 0 degrees from each other. I think I read that somewhere in the book. But because you're adding the two vectors together, they're not going to become one. They're just going to touch. So they're just going to touch tail to tip or tip to tail, and they're going to just continue. So that's how you.
And the R just runs all the way through it.
Right.
Okay.
So yeah, the y just would be 180 degrees, wouldn't it?
Yeah, I said 0 degrees like from the other. So like even though it is at a 180, it's like it doesn't move the tip from vector A and the tail from vector B. Like there's not a single degree of like, I guess from that point. So it would be either 180 or 0.
Yeah.
Okay, then that's what I put.
Okay. And then I said that the opposite was true. The smallest magnitude would be if they were going in opposite direction, but parallel. I don't know if that's right.
Cool.
Number 5. What did you guys think about number 5? I can.
Okay.
Kind of like number 3.
Yeah.
Oh, did you guys do the same thing for 5 that you did for 3?
In a sense, kind of.
I found 5 a ton easier than 3, but if I was supposed to do the same thing, Okay, yeah. So see, so my thing was like, because in 3 you were just given the result and you needed to find the A and the B, which I found way hard. But then in 5 and 6 you had the A and B, and you just needed to find the R.
Yeah. You're just using a different thing. For 5, you use side, angle, side, or vice versa. So you just basically, so you just use the equation c squared equals a squared plus b squared, subtract 2 ab cosine. So what you guys get for 5?
I did not get 5.
I got 92.3 meters.
So did I.
Okay.
Okay. Can you put that up really quick? One of you that got it? I don't know.
Yeah, I'll put it up.
Because I'm seeing like that formula in my head. I just can't picture it.
I actually didn't put. Yeah.
B squared, and then a squared b squared minus 2ab cosine. Okay.
B squared.
Minus 2ab cosine. Yeah, it's been so long.
Okay, dude.
Did someone say something? Did one of you girls say something?
Yeah, sorry. I was just making sure that I had the same angle that all of you had for that cosine theta or whatever. And yeah, I also got 58 degrees.
So where did you get that 58 degrees?
The 58 degrees, I did it by creating a right angle. So if you were to, you see that? I'll put it back up on.
Sorry.
Can you see my mouse when I do this?
I should be able to. No. Yes.
You see it? Okay. So you see this dotted line right here?
Uh-huh.
If you continue that dotted line all the way to the y-axis, it creates a right square.
Right.
And so since I have a right square, I have the one angle, which is a 90. And then I have, oh wait, which one am I talking about?
It's going to make that angle.
Wait, no, I'm looking, I found the angle from down here.
Oh.
That's the angle I used, my bad. And so off of that, I did, since I have a 90, or how did I do it? I'm trying to remember now. Good question. So I did it with, so that's 11 degrees off of 90. Okay, yeah. So I see what I did. Okay, so we have this 21 here.
Mm-hmm.
You have a 90 here. And so you would take the 90, or the 180, subtract the 21, subtract 90, which gives you from the dotted line to this one. And then you subtract 11 from that.
Got it. Okay. I see.
And then once I got that, then I can use the side angle side, use the equation, plug it in.
Perfect. Awesome. All right. Any other questions? If not, number 6. More of the same.
Yeah.
I'm really not getting this, but now I'm starting to. Okay. Anybody else want to talk about how they did this one? Mason, I know you've said a lot already. Did anybody get it?
I have it. Or you can go ahead, Sarah. Got it.
No, I wasn't able to get this one.
Okay. I can try to show it. I only have it on paper. Oh, the lighting is so bad in here.
Yeah, it's okay.
Okay, well, I'll just explain what I did. Let me see if I can make this happen. Okay, so you see my screen? Do you still see my screen?
Yep.
So do you see the problem here?
Yep.
Awesome. Okay, so so what I did for these is you're trying to find this R, the R total. So I found the Rx and the Ry, and then plug that into the Pythagorean theorem for a triangle right here. Does that make sense?
Yeah.
Okay, so I set Rx equals, and then you want to plug in Rx, so to find Rx, you do 40 kilometers times the cosine of 60, and then you add that to 30 kilometers times the cosine of 15. And that gave me 48.98. And then you do the same thing for your y. You use the same values, except for instead of doing cosine, you use sine. And that gave me 42.41. And then I just use the Pythagorean theorem. Sorry, I wish I could show you my paper. Make it clearer.
It's okay. That made sense.
I don't know. I don't even know how I got to that. How do I get out of this? There we go. I don't even know how I found that formula, but it worked.
So what ended up like in total were your two answers for this one?
For the Rx and Ry,
For
or
the
for
X
the
and Y.
for the answer?
For the answer.
64.8 kilometers. Yeah. Did you get that, Mason?
Yeah, that's what I got.
So I guess his way or my way, they both work somehow.
That's all that matters, right?
Yeah.
Yeah. So Mason, did you do yours in a different way?
Yeah, I found that one angle, and once I had that one angle, I did the angle or the side angle side again with the same formula from the last question and solved it that way.
Got it. Yeah,
Actually, we just need to get all the trigonometry rules in our notes for this exam.
I
That would be
know.
very
For real.
helpful.
Oh my gosh. I think the last time I took trig was in high school.
Oh wow.
So yeah, it's been a long time. Anyway, yeah. Okay, that makes sense. I like using the X and Y components because I think that makes it really clear you have a right angle. So it's a really good way to do it. Okay, any other questions on that one? All right, let's go to 7.
Oh wait a minute. I think there's another part to 6.
Is there?
Oh yeah. Then you need to find the angle.
Oh,
Sorry, I just remembered.
no, you're fine. Find your total distance.
I don't know if I did that right, but to find the angle, I did the inverse of tangent, and I did 42.4 over 49, and that gave me 40.9, which would be north of east,
Yeah, I got that as
and
well.
that's the degree.
How'd you do it?
I did the inverse of tangent, 42.4 over 49 degrees.
Where'd you get those numbers?
Got the 49 because, sorry, my paper is all over the place. I had to find where I found it now. I know at one point, so for the x component, I had 20 kilometers and 0.9 kilometers, and I add those together to get the 49 kilometers. I added by adding the components, which is 34.6 and 7.76 kilometers. And that gave me my total. That gave me the tangent inverse that I was able to do.
Yeah, those are the same values I had for the Rx total and the Ry, or the Rx and Ry values.
I'm really bad at explaining.
No, I don't get half of the stuff.
I wish the tutorials were a little bit clearer and went into more depth because I feel like they just scratched the surface and then.
I know. I feel like it'd be nice if he had just an extra document that had all the list of all the equations we need to know. Because I feel like I'm going through the book and I never really find super clear formulas.
Yeah.
I don't know.
Well, I don't know if you guys.
All right, so
Oh, sorry, Mason. What were you gonna say?
What was the angle again you guys got? I'm just trying to figure out. What was it? 40 what?
40.9.
40.9.
I don't know if you guys have used his office hours or not. I have gotten online, but they're super helpful. He walked me through the lab yesterday and last week, and so he's got another one tomorrow, which is good before the test. But they're like super helpful because he'll show you exactly how you're supposed to walk through the problems.
Do you know what time it's at tomorrow?
I think it's 6 to 7 tomorrow, and that's Mountain Time. So, alrighty, number 7. So this one, I said 14.225 degrees. I don't know.
That's what I got.
Yeah.
Same thing.
Did anybody not know?
That's what I got.
That one was pretty easy, I thought.
I got that. Wait, you said 14.225?
225, yeah.
Yeah.
And then for part B, I said that the other angle would be the complementary angle, so I just subtracted it from 90 and got 75.775. And I said you wouldn't use that one because you wouldn't throw the ball that high up in the air. You would throw it out more than up. So
I put that as well.
That's what I got.
cool. And then how long did the pass take? This is where I struggle. I can't figure out which formula to use for time, to figure out time, ever. I couldn't figure it out in the lab last night because I just get confused on if you're using the the X component or the Y component.
We're doing the X.
Okay. Because you're looking at the how far it travels?
Mm-hmm.
Okay.
Whatever I want to get. I got 0.583 seconds.
I was confused on this C2.
Yeah, I didn't know what formula to use. I got 2.45 seconds.
Let me show you. This is what I did right here. Let me get it up here. So I just used this formula that they had in the lab, whatever thing the other week that we did. I just filled it in with the numbers that I was given in the question. I don't know if that's right or not, but that's what I did.
Looks right to me.
7. So that'd be 7 equals 0 for the initial distance plus 12 time. Okay, yeah, that makes sense. And plus, I mean, 2 seconds. My answer is absurd because it's only 7 meter distance and it's moving at 12 meters per second, so it should definitely not be more than 2 seconds. So yeah, your answer makes sense.
Cool. Yeah, I got that now. Five, 8, cool. All right. That was it, right? There were only 3 parts to number 7.
Yes.
All right, number 8. This one was another fun one. Who wants to talk about this?
So I got 2 conflicting answers for this one. So on A, please let me know if anybody has the same answers, but for the height of the cliff, I got 105.42 meters. But then for the max height of the arrow, I got 35.94 meters. And that doesn't make sense. I think I did many things wrong. Yeah.
What did you say that you got for the height of the cliff?
For the height of the cliff, I got I got 105.42 meters. And that was just from using the projectile equation y equals y naught plus velocity of y naught times t minus 1/2 gravity times t squared.
Mm-hmm. Right. Did everyone else use that one to get it?
I got something different. I don't know if I did it right, though.
Oh.
Sure.
I got, for the trajectory, I got 30 0.716 meters, and the height of the cliff is 32.216 meters.
Huh.
Cool.
Well, that's conflicting. Well,
How did you do it?
I don't know. It's kind of confusing.
nice picture. Good picture.
Yeah, I like pictures.
That's good.
I don't know if that makes any sense at all. Let's see if I can show you my screen here. This is kind of what I did. I just took. So I took one of the equations in the lab again, the little reading part in the beginning,
Mm-hmm.
and then I plugged in the numbers for what I had, and then found my y. And then the guy's saying on a 1.5 meter like step thing. So I figured the trajectory should be from where he's standing to the top, because the arrow hit the top, and then you just got to add the 1.5 to get the whole cliff, height. And then I did the same thing for the velocity. I just found the equation that worked for it and got the ending velocity, the velocity. I can't speak. The negative 9.2 meters a second. But I could have completely done that wrong. I don't know.
So
That looks right.
The only thing that we did different was when I plugged in the acceleration of gravity, I put, so it's negative 1/2 or minus 1/2 times.
Yeah.
And I put negative 9.8 since it's going down, but you put positive 9.8. So should I have put positive 9.8?
I don't know. I thought it was supposed to be positive. It could be negative. I don't know. Let's see what happens.
Well, so I couldn't find A. I didn't know how to do it. But for B, for its maximum height, I got 36 meters and final velocity 20 meters per second.
Okay, I got approximately the same height as you did.
So I thought it was supposed to be -2, but for some reason in the lab, I always was putting it in negative, and then I would end up having to change it to positive because it wouldn't be right. So I'm really confused on if it's supposed to be positive or negative.
Yeah.
If you look at the lab in the little top part, it says acceleration on the due to x is 0, and the negative g equals negative 9.8. And so I think negative gravity means it's going down, and that's when you have the negative 9.8. But it says the acceleration of the object is always straight down with a value of 9.8 positive. So I think it's supposed to be positive, but I could be wrong.
Where I got that from?
What was that?
So that where I got it from? I don't know. I thought it said something in there.
Because it says negative g equals negative 8 or 9.8, and so that would mean that g equals positive 9.8. And then in the the very first paragraph, it says, in cases where we can neglect the effects of air resistance, the acceleration of the object is always straight down with a value of 9.8 positive.
It says positive after it says 9.8.
It says positive 9.8. I just was clarifying that it's positive.
Yeah. So my thought, so the way I understood that was when it says, because you know how we're supposed to look at these things as a grid,
Mm-hmm.
like X and Y axes. So we're looking at the arrow going up and to the right. And so I always thought, so in this instance, since the 9.8 is going down, it's negative because it's pulling it down. That's why I've always thought it was a negative 9.8.
That's what I thought too, because the acceleration is going downwards with gravity.
Right. Yeah, that's why I always put it in as negative too in the past.
Yeah, but I think if we were looking at it as no, I don't even know how that would work actually. Never mind, I'm not going to say that. I don't know.
Where you have air resistance when you're going up, so it's going to be a negative because it's pulling it back down. But if you're going down with gravity, it's going to be positive because there's nothing pulling it back. So it would make it a positive.
Yeah,
This is true
that
as
makes
well.
sense.
That is true. Yeah.
So Yeah. So for B, I use the equation v squared equals v naught squared plus 2a, and then the height. And so I just solved that out. So for the height of the arrow, I got 34.44 meters, and then you're already 1.5 meters off the ground. So then I added that to get the 36 meters for the the total height. Did everybody get that?
Yeah.
That's what I got.
That sounds right. Okay. Hang on. Sorry, I'm trying to do calculations really quick.
Somebody really quick wanted to explain again how you found A.
I think I did it wrong.
I have no idea how to do A.
So wait, how'd you guys do B again?
Try to show you this equation. Okay, right there. It's this equation right here.
You took 30 squared, sine of 60 squared.
That's the angle that he shot the arrow. He or she shot the arrow.
Yeah. Plus 2. 9.8. Jeez. Okay. That makes sense. Makes more sense than what I put. I just added 1.5 to my answer for A.
So then B, we said you're using that equation. Are you using that maximum projectile height equation? Is that the one that you were saying, Landon? About that velocity squared or B squared equals B naught squared plus 2A.
Mm-hmm. Yeah, that's the one I used.
Okay. All right. But we also have differing answers. Is that right? I don't really know what to do from here.
I don't know which ones are right. I wish there was an answer key.
I know.
Yeah.
There is once we submit it, but it doesn't.
Awesome.
I know.
So what are all the answers out there right now?
So I got 30.716 meters
For the height?
height.
Okay.
For the trajectory height.
Okay, so yeah, so for part B.
Oh, for part A. I'm sorry, what part are we talking about?
Well, for all of them. So for part A, for the height of the cliff, what did you guys get?
I didn't get an answer for that.
So I put it into the formula that you were saying, Mason.
Uh-huh.
But I got 43.1 for the Y. So I don't know, because I did.
Did you do a negative or positive?
I used the positive 9.8.
Positive 9.8.
And then I multiplied that by the 4 squared, which is the time, and then divided it by 2. And so then I just subtracted that number. So I had the 1.5 plus 120 minus 78.4.
Well, let me redo mine to make sure I got the right answer, the same answer. 60. Four. Right. Yeah, I got the same answer again, 30.719.
Huh.
Oh my god.
Yeah, I know. What the heck?
Okay.
All right, hold on. Let me show you what I did. Maybe
Yeah.
I wrote it differently or something. I don't know.
Yeah.
Okay, let me pull it up here. All right, so this is the equation I have here. Wow, that's freaking out. So I have the 1.5, which is the ledge he's sitting or standing on. plus the 30, which is the meters per second.
I see what it's because I didn't put in that sign of 60. So that's
Oh,
where
yeah, for the angle.
yeah, I didn't put in the angle. I just put in the initial velocity, but it's the initial velocity in the y component. So and yeah, I see now. And I solved that one up there. But I didn't put it back in. Okay. So then now it's 25.98 times 4 plus 1.5 minus 78. Sorry, guys.
Wow. So I just plugged that exact equation into my calculator, and I got 27 meters.
That's what I got. Yeah.
Really?
Yeah. So I got the Vy naught to be 25.98, which is that 30 times sine 60. And so then I put in that number times 4 equals 29.98. Then I added the 1.5. And then if you look at that whole section, the last section, the 1/2, 9.84 squared, I got that answer to be 78.4.
Okay.
So
Now
I
I'm
did
getting 27.02 now.
27.02. Or point
Oh,
zero
I don't know what I
something.
did to enter it. Yeah,
I don't know how that
I don't know
happened.
how I got that. 27.02.
Yeah. Cool. So now we all have the same answer for that. But that's the height,
Wait,
right?
is that A or B?
That's
A.
A.
Okay, yeah.
And then for B, if you want to just leave your screen up there.
Yep.
So now we have the Y and the Y naught, and we have the Vy naught. So, oh wait, no. Are we using that maximum projectile height formula? Sorry, I'm like way lost. What answers did you guys get for that?
For the max height, I got 35.94 meters.
Okay.
Yeah, I got the same.
Okay.
And how'd you do that?
I use the equation velocity of y squared equals velocity equals v naught y squared plus 2a times y minus y, so y minus 1.5.
Okay. All right, you want to walk me through that so I can type that up and so I can submit it?
Yeah.
Yeah, so the final velocity squared is going to be 0, right, because it lands on the ground.
So 0 equals?
0 equals that 30 times sine of 60 squared plus 2 times, I put negative 9.8 because gravity's acceleration is downwards.
Plus negative 9.28?
Plus 2 times negative 9.8 times y minus 1.5. And that y minus 1.5 is in parentheses.
Like so?
Yep.
Okay.
Yep.
All right, I gotta punch that in real quick.
Just let you know my bandwidth, so I have to go.
Well, who's that?
That's me.
Oh, okay. All right.
Yeah. But if you have any questions, I'll still keep my email open. So,
Okay.
Sounds good.
okay. See you next week. Oh, please also Email me what questions you want me to work on.
Oh, okay. Yeah, we'll figure that out.
Okay.
Cool. Thanks.
Okay. Bye. Bye. All right.
All right. Well, last time, what was the answer for B? Let me make sure I got the same thing.
I rounded it to 36.
Round at 36. That works for me. I can round at 36 meters.
I think that's the amount of sig figs they gave us in the questions. That's why I rounded it to that.
Yeah, that's fine. You guys can just go on. We'll just move on from there. I can go back and look at it. All right, all right. So number 9. This is just a conceptual one.
Oh, I'm sorry. Did we do velocity?
Oh no, we didn't. We didn't.
I'm sorry. Oh, I'm so sick of 8.
No, I know. You're fine.
Okay, let's see. Okay, so what is the arrow's impact speed just before it hits the cliff? I got 20 meters per second.
20 meters per second?
Yeah.
Sorry, my computer's gonna die.
I got negative 9.2.
I did not answer.
Well, and I'm trying to think how I got mine. How'd you get your answer, Mason?
So I used the let's see, the original. I got to pull it up on. So from week 2, that lab. Let's see if we can get it here. Where are you at? There it is. So in the week 2 lab, get your main tabs open. There's an equation in week 2's lab that says V equals V naught plus AT.
Mm-hmm.
And so I put in my numbers that I had for the equation, which was, so my 30 was my V naught, so my initial velocity. And then subtract my A, which is my constant gravity, so it's 9.8. And then my time was 4 seconds. So I put the equation of V subtract 9.8 times 4, which gave me negative 9.2 meters a second.
Well, when I used your equation, I got the same thing. But when I'm thinking about it, we can't have it. Can we have a negative velocity?
Because it's impacting
That
the
means it'd
hill.
be going backwards. Huh?
It's getting impacted by the cliff, so I figured it would be a negative.
So it's saying, what is the velocity just before hitting the cliff?
I don't know.
I don't know what equation we would use. How did I get 20?
What if we use the negative 9.8 there? Would it give us a positive velocity?
Instead of subtracting it, adding it? Is that what you're saying?
Yeah. Well,
30 plus the 9.8 times 4. I have 69.2.
oh, yeah, that's too fast.
V equals V naught.
Oh, no, that's not the change.
Let me check something really quick.
Did you use the equation, the change in X over the change in time?
Oh, no, I use the change in V over change in time equals acceleration. But I guess we could do that too.
Trying to find the one I use, but I can't find it.
So would we use that height as the X? No. Do we know X?
X final? I don't think we do.
I mean, I guess we could
I mean,
find
you could
it.
put the equation.
You could.
Range one. That just seems like a lot of work.
Yeah.
Like it seems like a lot of steps for just one little question. You know what I mean?
Mm-hmm.
But I'm gonna try it now. 30 squared.
And I'm hoping that the exam doesn't have a question like this one. Just
Yeah, for real.
When you got the 20, did you get 20.2?
Something like that.
Because the way I got 20.2 and I did velocity well, I did the, what formula is this? The vertical height formula, and that's what gave me the 20.2.
Interesting. Well, so I used so velocity squared equals velocity of x squared plus velocity of y squared. So kind of like a Pythagorean. Find the velocity of the y on the y-axis. I did the initial. How did I do that? Yeah. So I used. You did, Mason.
Mm-hmm.
Well, let me see. 30. So instead of just v naught, I did 30 sine of 60 and
So you
plug
added the
that in
angle
for v
in.
naught. Yeah, and so then that gave me 13.2 meters per second. And so then I used that as the velocity for y. So then if you take total velocity squared equals velocity of x squared, which is 30 cosine of 60, and then plus the 13.2, then that gave me 20. Oh my gosh, it's
You got
such a
around
mess.
20 for your velocity, is that what you said?
20, yeah, I got 20 for my final velocity.
So I found the range, so I found the x component because I did the initial velocity squared divided by acceleration times sine 2 theta, which is sine 120 degrees. And then I got a range of 79.53. And I put that one into the velocity equals the change of distance or the change of position over the change of time. So I did the 79.53 over the 4 seconds and I got 19.88. So that's pretty close to 20.
Yeah.
So I think we just did it different ways, but I think it got us the same answer.
So you want to round up to about 20?
Yeah. I like your way a lot more than the way I did it.
The way that I did it?
Yeah.
Yeah, I mean, it does seem like a lot of steps and it's a lot of different formulas, but it kind of makes sense. So I don't know.
Okay. Yeah. So I think we agree on 20 meters a second.
20. Yep, I'm okay with that. I like it.
I like it.
Okay.
Okay.
All right. So can we move on from 8 now?
Yeah.
Yes.
I think this is going to be a lot easier when we each do like 1 or 2 questions and like really understand them.
Yeah.
Okay. This is just a conceptual one, so this one's easier. But if someone's riding on the back of a pickup truck and throws a softball straight backwards, is it possible for the ball to fall straight down as viewed by the person standing at the side of the road? What do you guys think?
I think it would be if the initial velocity is equal to the truck's velocity, but that's just what I thought.
That's what I said as well.
Agreed.
Okay. And then under what condition would this occur? Oh, yeah, we said same velocity. And how would the motion of the ball appear to the person who threw it?
I think it would look like it was going a lot farther than it really was because he's still moving.
Because the truck's moving. Yep. All right, cool. And then number 10.
Okay, so I was able to find half of it, the how fast he was moving. Wait, how fast is the water? Oh, yeah, never mind. I got it. Oh, I had the answer. I didn't even know it. I read it wrong.
How'd you guys do it?
I don't know if I did it right, but I took 25 and I divided it by 0.5 to give me 12.5. Then I did velocity over distance and time, which would be 40 divided by 25 to give me 1.6 meters per second. And then I took the 1.6 squared plus 0.5 squared, and I got 1.68 millimeters per second.
Hmm.
But that's probably not right.
I got something different. What did you two get, Lauren and Mason?
I did not get this one.
I got 1.6 meters a second for the, what was that? The speed of the water
The water.
relative to the ground. And then for B, I got 1.68 meters a second.
I got different answers on everything. Alrighty.
The two answers.
You said you got that same answer, Ashley?
Mm-hmm. Yeah, I got 1.6 and 1.6.
Do you want to show us how you did that, Ashley? Or kind of tell us how you did it?
Because you have the 25 meters, and I divided that by 0.5 to give me 12.5. Oh wait, I don't know why I did that.
You kind of
what I just said. I don't know why I said that. Sorry. I did velocity equals distance over time. I did 40 meters divided by 25 meters to give me the 1.6 meters per second. And then I took the square root of 1.6 squared plus 0.5 squared to give me the 1.68 meters per second.
Perfect.
What I did.
Yeah, that makes sense to me.
Oh, I did that 12.5. That was weird.
You're fine. So that's okay. And then what? Okay, so it was the same speed for both. 1.6.
1.6 and then 1.68 if you know, or 7 if you're round.
Okay. Alrighty. Any other questions about that one?
No, sounds good.
Sounds good to me. All right, Mason, do you have everything you need to submit that?
Yeah, I just gotta save the changes that we made and then I'll submit it as a PDF.
Okay, and then I'll just go in and submit. Do they have to go into the discussion board? Actually, let's take a look at that now that we've finished. Can we put them on the discussion board like as like two separate things, or do we have to? I know there's a place to submit, but I don't know.
You're the one who like did the recording. You put a link to like the recording, and then you put like who was all there in the participation, and you submit that as like a Word document. Then the other thing is a PDF document.
Okay, so but we can submit two separate documents. I
think so. I think because I think there's.
I can always send it to you as a PDF if you want.
That's true, and then I could submit it. But I'm trying to see. Yeah, it says group work submission because I thought I read something that said you can submit as many times as you'd like, but only the last one will be accepted or something. So that's what I was wondering if they had to be together.
I don't know. We'll just submit it together to be safe, and then.
Yeah, and then we can figure it out for next week. But yeah, if you'll just send it to me then, Mason, and we can. Okay. I'll submit both of them together right now. So then the last thing is for next week, how many problems are there and what problems we want to each do.
Yeah.
4. Group work. So
there are 11 questions.
Okay. Is there
they'd
like
split
a
into
conceptual one? We can do two.
There's the first one's a conceptual.
So we could do like 1, 2, 3. And 4 is a conceptual too. So should we do 1, 2,
There's
3?
10 is also conceptual.
Okay. Is there one that looks bigger?
10 is a bigger conceptual than 1.
That's a little bigger. Okay, so should we just divide it 1, 2, and 3, and then 4 and 5, 6 and 7, 8, 9, 10, 11?
That
I'm
works
good
for
with
me.
that.
Okay. Any preferences? Anybody want the first 3?
I don't mind either way.
I can
Okay.
do 10 and 11.
All right, so we'll just remember who had what. I can take 1, 2, and 3. And then maybe we'll give Sarah 4 and 5.
I'll take 6 and 7.
Okay.
And then Mason 8 and 9.
Mason 8 and
8,
9.
9.
Alrighty.
Okay.
Awesome.
And I'm sending that right now.
Perfect. And I will submit it as soon as I can get the video uploaded because it takes a little while.
Okay.
So
Awesome.
I will download that and then submit it all tonight, and we can do our participation, and we're good to go.
Sounds
Sweet.
good.
All right.
All right.
Thanks,
Thank you,
guys.
guys.
Thanks for the help.
Appreciate it. See you next week.
See you next week.